Welcome to today's Adventures with Bill, and on today's video I'm going to be showing you how I made this really cool desk lamp. Now, industrial design or automotive car parts, motorcycle parts, that's the hot trend in today's design. This desk lamp is the first piece in my line, which is called Steampunk'd by Bill. Now, Steampunk'd is another type of fashion. This doesn't fit exactly into that category, but regardless, it's going to be part of that line. This particular piece was made entirely of recycled automotive, motorcycle, and other industrial components. So watch the video, if you will, from start to finish. You'll see it step by step, how it took shape. I hope you enjoy it.
We're going to start out here by making the base from a brake rotor for a car or a truck. I'm going to clean it off with acetone before we cut it in half. You can see I'm using a straight edge to mark where I'm going to cut it. It'll be just a little bit more than halfway, but when I get finished, I'll be able to use both halves on two different projects. The way I'm going to cut it today is with the plasma cutter. I begin cutting and it's really not doing anything. What's wrong with the plasma cutter? Well, you have to have the ground clamp on the wheel or on the rotor. So using it the right way, you can see it cuts through this like butter. And I'm going to speed up several parts of this process just so you don't have to watch the whole thing. But the plasma cutter does a great job, except for the bottom section, because there's an air gap. It didn't cut all the way through. So I just cut it on the back side. I could have used a cutoff wheel or an industrial bandsaw to do the same thing. You just use whatever tools you have available. A little gentle persuasion and the slag breaks free, and there's your two parts. You can see the plasma cutter makes a pretty rough cut, not super smooth, so I'll be using the 4.5-inch angle grinder with a grinding wheel to clean up the edges, get it perfectly flush. And the parts that I'm making this from are heavy, industrial, automotive, and motorcycle parts. The finished lamp project weighs over 15 pounds, so you're using substantial parts, and your welding has got to be top-notch because you don't want this thing to break. So there's just a picture of the two parts put together, the two halves, and like I said, I'll use this other half to make another lamp project. Now I'm just test fitting up some different mechanical components that I have to get a good visual idea of what this project's going to look like. And this is where the creative part kicks in. You want something that's visually appealing, it's right proportionally, and you've got freedom to be creative here. So I'm just mocking up several different assemblies, trying to find the one that I think is going to look the best. That's a motorcycle camshaft that I'm using there, along with another motorcycle part, gears, timing gears, and that to me looked pretty good. Thinking about maybe putting this bullet-shaped piece on, but it's not quite going to be the look that I want to go for on this. So I decided to use this timing gear and again mark it a little over halfway where I'm going to cut. And for it, I'm not going to use the plasma cutter. It'd be just a little easier. Here I'm using that 4.5-inch angle grinder with the cutting wheel. Use the grinder again, the grinder attachment, and smooth the edges off. And I'll have two pieces for two different projects. I know the lighting's not very good, but here's where I'm beginning to mock it up. Whoops, got to keep everything balanced. But I kind of like the progressive look of this, the way I've got it assembled. So the first thing is to weld that gear onto the brake rotor. I'm using a MIG welder with stainless steel wire. Here is some nozzle shield spray. It's best to spray on your parts before you weld and also on your workbench and on your clamp so that the welding spatter won't stick to everything. Well, there must be a little oil in that bearing because you can see it flames on, but it's no big deal. And of course, with the welding, the grinding, the cutting, everything you're doing, you're wearing the appropriate safety gear, the right kind of gloves, eye protection, ear protection, and sometimes even a mask to keep from breathing in the dust. Now that that's welded up, I ground the back edge of the weld smooth and try to see how these other parts are going to fit up to it. And that, to me, that's looking pretty good. So MIG weld, again, I'm speeding the process up. I eventually end up welding this all the way around, and then here taking the grinder and cleaning up the weld, polishing it up so that it looks halfway decent. It's starting to take shape now, getting near the finished height of it. And this is the valve cover. This is a Mickey Thompson cast aluminum valve cover. These things are nice. All of these parts are genuine automotive or motorcycle parts. They're not reproductions. There's a lot of cheap reproductions out there. Here I'm fitting up a piece of pipe to cut off to attach the valve cover to the rest of the lamp assembly. So I'm just checking it to see the length that it needs to be. And this piece will have to be modified quite a bit before it is exactly the way we want it. So again, you're doing most of this by eye. It's kind of a creative process, trying to see how much of this bracket is going to need to be cut down. And I've got the cut down section now in the drill press, and I'm just drilling the 2 mounting holes in the bracket that goes on top of the assembly. I'm grinding off the black paint because it's got to be bare metal to weld it for the weld to work good. And we'll end up painting this black at a later stage after all the welding's complete. This is the hardware I'm going to be using, just checking to make sure it fits. Goes onto the top of the assembly like that. I'm going to weld it in place, and obviously need a little bit of adjustment here to flatten that out instead of a half round to get a better fit on the valve cover. Test fitting the valve cover itself, see how it's going to line up, and I think that's looking pretty good right about there. So welding that piece on, I welded it from the inside. You can see as it glows red all the way through to the outside. I'm getting good penetration on the welds. Again, this is a heavy piece. Do not want it coming apart, falling apart. So now I've got a mark on the valve cover where the 2 holes are going to be to drill through for the mounting hardware. Put the piece in place on the valve cover, transfer the holes with a magic marker. That's where the valve cover is going to get drilled. And you might notice I make a mistake at this point. There's where the holes are going to be. I'll use a square and a sharp awl to scratch an exact placement for those 2 holes. Begin drilling them with a regular hand drill with a small size pilot hole to start with. Then I'll go up to the clearance drill to give enough clearance for the bolts to go through. You've got to make sure the drill's turning the right way. And then that aluminum drill's pretty easy. So now the larger drill bit from the outside, there's the 2 mounting holes. I mentioned a mistake I made. I actually drilled those holes on the front of the valve cover when I wanted it to be on the back. You can see there that the Mickey Thompson is upside down. Well, you know, you almost always make mistakes when you do these projects, so I'm going to flip it around and drill 2 more holes on the back. Here it is on the back now. So it's mounted the right way. Those 2 holes are going to get filled in. I thought about putting the on-off switch in one of the holes, but decided against that. I'm going to put the on-off switch on the side of that valve cover. So this is just it, welded up, polished up, temporarily have the valve cover in place, but we got a lot more work to do. Here I'm making the bracket that's going to attach and hold the light bulb socket. Here it is bent up. I marked it off, I bent it up, ground the edges for clearance, and I've got to drill 2 holes through it as well. And I'll wait to drill the holes until after I've welded that bracket on. So again, I'm using the MIG welder with stainless steel wire. It's my first attempt at using stainless steel wire with no flux, just the argon gas, and it's stuck on there. It's not going anywhere. And here it is with a LED bulb just test fit in place so you get an idea of what it looks like. Cleaned everything really down really good with acetone, and taped off with masking tape the parts that won't get paint. So the first coat you can see here is the gray primer, so that the paint will bond to the metal. Starting the base coat of black, kind of a matte black. I don't want a glossy finish on this. I could have used gloss paint because you can see here how it's a kind of a flat black. That's the look I'm going for, but I clear coated the whole thing after I got all the colors on, and I used a matte or a satin finish clear coat, so I could have used gloss paint at this stage. It wouldn't have made any difference. There's a couple sections here that you can see are going to be getting the black, matte black, be alternating between the shiny steel and the matte black. Couple coats. At this point, I'm giving the little red highlight, the fins on the bottom of that brake rotor, I think are going to contrast really nice. And the fun part of every project after you paint is unmasking it. You get to see your creation come to life, so to speak. And not a good camera angle, but you can see the contrasting black painted surfaces with the metallic surfaces. And I'm thinking it's looking pretty cool at this point. So yeah, here's a close-up, how that black and that red and the steel all work together. Of course, the valve cover is going to be painted. I could have just polished aluminum, but this is a Chevrolet valve cover for a small block Chevy engine. And Chevrolet has their orange. Ford has blue. Different brands of vehicles have different colors, and this is the official Chevy orange that they will find. You'll find painted on the engine blocks, other parts of their engines. This is a self-etching primer that you need to use on aluminum. And here it is. Man, it looks pretty good just in primer. Mickey Thompson with the Chevrolet writing on it. This is a sharp-looking valve cover, but we're not going to leave it in primer. Got to add the color to it. And so I start with a light coat, and of course I'm speeding this up. First coat of orange, and we will come back with the second coat to give it a really nice high gloss finish. Now while we're painting it, putting the second coat on here, I believe, I do want to mention that these parts that I make are for sale. Now here's the base with the clear on it, and it's kind of glossy because the clear hasn't dried, but I'm still thinking this is looking pretty sharp. Now here it is with the second coat, and the lighting, this looks kind of red, but it's just the camera. It's not red, trust me. It's that bright Chevy orange, engine orange, and a couple good solid coats. There it is. I think this shows the exact color a little bit, and this is an awesome piece. And now that it's finished, it is for sale, and I'll have details on my website. You can check out my website, adventureswithbill.org. For more information. This video will be posted on there, and you can see similar items that are made. People sell them on Etsy. They'll post them on Pinterest. Some of them are made, again, using reproduction parts, so they look authentic, but they're really not. This is all industrial, automotive, motorcycle parts. This is the real deal. Anyone that knows their mechanical items will recognize this. Wiring the light bulb socket into place now. Going to have the switch located on the end of the valve cover. And it's a rotary switch, which you'll see in just a minute. But this is just getting all the connections for the light bulb socket. There's the rotary switch. You just turn it clockwise, on, off. Neat. I mean, it's in the right place, I think. Looks great. So the next step is actually to install that valve cover, and it's getting pretty close to the final appearance of it. A couple quarter 20 bolts, nylock, so it doesn't vibrate loose. And even though these bolts are substantial holding it in place, I drilled the holes a little bit of oversize to give me some adjustment. And you can see as I'm tightening up, the valve cover will tilt from right to left. But we're going to take care of that using the impact screwdriver here to snug those up nice and firm. Now, like I said, I want this valve cover to be perfectly level with the tabletop. So I'm measuring it here to make sure it's perfectly level. I've got a pilot hole drilled in the valve cover. Now I'm drilling another hole through the mounting bracket, and I'm just going to put a small 10-24 screw there, and that's going to lock it in place so that the valve cover won't tilt right or left. We don't want it looking crooked. This thing's got to be right, and it is. At this point, I've moved inside the house on the kitchen table, much to my wife's chagrin, and I'm just making the connections to wire up the light socket to the mounting switch and then to the electric. This is a 110 volt setup, so I'm bringing the lamp cord here inside the valve cover, and you got to strip the ends off. And I'm using wire nuts for these connections, but as you'll see, along with a good connection with the wire nut, you also need to use electrical tape to tape those wire nuts in place. It has happened in the past. Sometimes you may not get one quite tight enough and it'll fall off. Well, that's a problem because you've got a bare wire exposed. This is the LED bulb that I'm using for this. You can use all kinds of light bulbs. It's a regular home light socket. Edison bulbs are nice for that more of a vintage look. But here I'm just putting the electrical tape over the wire nuts so that there's no way they can fall off. Tuck them up in out of the way so they won't be seen. I put a couple holes in the mounting bracket so that I can use these nylon zip ties or tie wraps to keep the wiring snugged up, out of the way, everything copacetic. Along with duct tape, those tie wraps are one of man's greatest inventions. Mankind, a woman might have invented them, I don't know. Running the power cord for the lamp down on the back side of the camshaft so that it's not visible when you're, from the front. Zip ties for that, snip them off nice and flush, nothing hanging out. And then on the bottom, got one more zip tie to go. Up underneath the base on the inside of the brake rotor, I'm putting these little sticky blocks that you can use to tie wrap the lamp cord out of the way so that it doesn't get pinched underneath the base. I use a couple of those, zip tie the lamp cord to it, and everything is copacetic again. These have really good adhesive, 3M adhesive, and they're not going to be falling off anywhere. You can see also there's 3 round rubber pads I put on the bottom of the brake rotor because, again, this is a heavy over 15 pounds lamp, and I don't want anyone to be scratching up their tabletop with it, so put those rubber bumpers on the bottom.
Well, here we are again with the finished product, and I hope you've enjoyed watching the video, how I made it. I plan to have many other projects coming up in the near future, so if you would subscribe to the channel, you'll be notified each time I put a new video up on YouTube. And also, if you wouldn't mind, hit the like button. That helps my channel as well. If you think you'd like to have a custom piece made for you in the colors or the shapes, the design that you would like, contact me. I'd be glad to do that. Down below this video in the video description, I'll have links to the different products that I use, and also have my contact information if you want to reach out to me. That's going to wrap up this week's video on Adventures with Bill, and until next time, God bless you.